In part 1 we showed that -1 times -1 came to +1 in a 4 circle.
Aha, me hearties! How do ye know that was not just a fluke? Fair enough. We'll try a different sum in a different circle. We want to show that -2 times -3 equals +6 in a 7 circle. Our first step is to find what number -2 points to in that circle. To do this, we begin at 0 and move in the negative direction 2 steps backwards. 1, 2. And we can see that -2 is a direction to the number 5 in that circle. We'll treat -3 in exactly the same way. Beginning at 0, we'll move in the negative direction, this time a total of 3 steps backwards. 1, 2, 3. And we can see that -3 is pointing to 4 in that circle. The sum -2 times -3 has become 5 times 4 in 7 circle. To work that out, we'll rely on the definition that multiplication is repeated addition. So we'll treat this as 4 lots of 5. Now you could treat it, if you wished, as 5 lots of 4, and you'd be quite correct, you'd get the same answer. We'll begin counting out our first lot of 5 at 0 and move in the positive direction. 1, 2, 3, 4, 5 steps. That's our first lot of 5. 1, 2, 3, 4, 5. That's our second lot of 5. 1, 2, 3, 4, 5. Our third lot. 1, 2, 3, 4, 5. That's our fourth and final lot, and as you can see, the answer is 6. Now 6 is the same as +6 in that circle, which we'll just confirm by starting at 0 and counting in the positive direction 6 steps. 1, 2, 3, 4, 5, 6. So there we have it. We've shown that -2 times -3 is equal to +6 in 7 circle. Har har! Ye won't be able to do this one. How can ye show that -2 times -3 is +6 in a 4 circle? Of course you can't. There is no 6 in a 4 circle, ye landlubber.
Well, we'll give it a try. This is our final example. We want to show that -2 times -3 equals +6 in a circle which doesn't even have a 6 in it. Our first step is to find -2 in that circle. Beginning at 0, we move in the negative direction 2 steps backwards. 1, 2. And there we are. -2 is a direction to the number 2 in that circle. We'll treat the -3 in the same way. Starting at 0, we'll move backwards in the negative direction, this time 3 steps. 1, 2, 3. And we can see that -3 points to the number 1 in that circle. So the sum -2 times -3 has become 2 times 1 in a 4 circle. It's no surprise that 2 times 1, meaning 1 lot of 2, comes to 2 in that circle. What is a surprise, however, is that we did not show that -2 times -3 comes to +6, which is what we were expecting. The problem can in fact be resolved, and to do so we'll begin by putting what we've just worked out to one side. There it is. -2 times -3 equals 2 in the 4 circle. We know that's correct. Let's now move on and find out what +6 comes to in that circle. +6 is equal to 0 plus 6, so we'll just count that out. Starting at 0, we'll move in the positive direction 6 steps. 1, 2, 3, 4, 5, 6. And there we go. We can see that +6 also comes to the answer 2 in a 4 circle. So -2 times -3 and plus 6 both come to the same result, that is 2, in the four-circle, and so they're both equal. So we have shown that minus 2 times minus 3 does equal plus 6 in a four-circle, even though there is no 6 in that circle. And that concludes our demonstration that a negative times a negative comes to a positive in a circular counting system.
That be fine for tiny circles where plus 6 might count out to 2, but in reality, on the straight counting line, that sort of thing never happens. Pirates be pirates and plus 6 be 6 always.
That's a fair comment. We'd better take a closer look at the straight counting line to see what it is really made of. In the meantime, we can always get real-life answers as long as we choose a big enough circle for our demonstration. That is, assuming it will still work in bigger circles. In fact, any sine law whatsoever can be successfully demonstrated in any circle from 1 to 1 billion. As the size of the circle gets greater and greater, the part we can see looks straighter and straighter. An indefinitely great circle would appear, to our eyes, to be perfectly straight. In it, numbers would march out endlessly to the right, and for each of these numbers there would be a corresponding positive number. There is no fixed limit on the size of the circle, so with it you could count the stars at night. Looking to the left of 0, we find we cannot name any of the numbers. For example, if we knew that this number was 10 billion, then that would make this 10 billion in one circle. It would no longer be an indefinitely great circle. So we cannot know these numbers at all. However, we can know that one place left of 0 is minus 1, 2 places left is minus 2, and we could go on indefinitely. Let's look now at the result that we have. The indefinitely great circle is indistinguishable from the straight counting line to infinity. They are one and the same. By viewing the straight counting line as a special case of an underlying circular system, you lose nothing. You retain everything that was true on that line. And you open the door to a new form of arithmetic based on those circles. It is particularly good for helping children with mental calculation. We call it circle maths. The world is round, and it is composed of subatomic particles which twirl in curved paths. It spins around the solar system, which itself is part of a rotating spiral galaxy. This and a billion others like it are moving through Einstein's curved space-time. So what could be more natural than that mathematics, which is meant to accurately reflect reality, should turn out itself to be circular in nature?